right, you guys want to say hi to Adam? All right, Adam, that was a little weak there. Sorry, guy. All right. All right, so dividing integers, not a big deal. Still really doing review stuff. Hopefully all this stuff makes sense. Hopefully you're going to have a nice quiz and a good first test. All right, remember, division is the inverse of multiplication. Division is the inverse of multiplication. And some would say this, every division problem has two corresponding multiplication problems. So 35 divided by 5 would be the inverse of, so they say, 7 times 5, right? Or 5 times 7. Some would say, division undoes multiplication. Multiplication undoes division. Not a big deal. To me, it's like non-consequential. I'll talk about it a little bit more here in a minute when we get to 0. All right, you guys remember the rules, right? Positive divided by a positive is a positive. You are positive. I am positive. It's good to be positive, not negative. And therefore, we all remember that a negative divided by a negative is a, and you're positive of that as well. Because we remember whether multiplying or dividing, if the signs are the same, the result is positive. And of course, if the signs are opposite, the result is negative. A negative divided by a positive is a negative, and a positive divided by a negative is a negative. And we know that. We even applied that in the homework last night. And so this is just a bunch of review, and it's not worth a whole lot of time, so we're going to go fast because you guys know all this stuff. So everybody says a negative 28 divided by a positive 4 is, of course, a negative 7. Because we can divide 28 by 4, and we can do negative divided by a positive is a negative. How many 4s can go into a negative 28? A negative 7. The opposite of 7 4s can go into a negative 28. Such is life. All right, so what do we got for B? We got, what, negative 15/5. And of course, we would say that is a negative 3. All right, do C for me. It's the only thing that has a little bit of challenge to it, though not much. What do you get when you do C? See what you can get when you do C. Do you see? Do you see what I see? High C. Middle C. Seesaw. See you later. Ooh, that's a bad thought. C-section. That one's not good. All right. C. Gotta think of another C to get that out of my mind. C to shining C. Negative 15 over negative 10 is what? A 3/2? Right? When you reduce a negative 15 over negative 10, you get a positive 3/2. Do you concur? Beautiful. Awesome. Amazing. Let's see if the blue light was on. All right. A little bit of terminology. A little bit of terminology. What do we call the 5? What's its name? You learned this back in probably 3rd grade, 4th grade maybe? What's the term for the number that you divide into the other number? Yes, Madison. It is the divisor. So in the fractional form, that 5 on the bottom is the divisor, right? It's what's divided into the other number. And what do you call the number it's divided into? Ethan? It is the dividend or or the dividend. The dividend. And of course, we all know, yes, ma'am. Sure, come on in. I see us, senor. All right, we're back. So, dividend is the -2, and divisor times the quotient is the dividend. Very good. Easy, right? Are you bored? I'm bored. Too easy. It's way too easy. All right. Next, special cases. Everybody says 0 divided by anything is 0. So, example 1. 0 divided by -4n is 0. In number 2, isn't a 2 cubed an 8? 2 times 2 is 4 times 2 is 8. 8 minus 8 is, therefore the answer to number 2 is 0. I don't care what's on the bottom. Square root of 2x, y, z, q, d, whatever. I don't care what's down there as long as the bottom's not 0. All right. And this kind of works well because what happens when you do -4n times 0? What do you get? 0, the dividend, right? What happens when you do a square root of 2x times 0? What do you get? 0, right? The dividend. Ah, it works. Everybody's happy, 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 happy. Did Brother Paulie say that, right? See, I can say that now because it's not just a Duck Dynasty thing. All right. And we know, therefore, as well, that anything divided by 0 is infinity, 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 not beyond. Okay. Infinity, not 0. 0 is not true. Anything divided by 0 is not 0, not 0, not 0. All right, let me explain again how it's infinity. So let's think about division again. Let's suppose this room can hold 10. 10. And I'm going to chuck into the room 2s. All right, I'm going to chuck 2s into a room that can hold 10. You tell me when to stop. 1 2, 2 2s, 3 2s, 4 2s, 5 2s. Stop, right? Because I filled the room up. And we know that 10 divided by 2 is 5. You can fit 5 2s into a 10 division. All right, so let's do a room of 10, and let's divide it by 0, and I'm going to throw in nothing, and tell me when to stop throwing in nothing. 1 nothing, 2 nothing, 3 nothing, 4 nothing, 5 nothing, 6 nothing, 7 nothing, 8 nothing, 9 nothing, 10 nothing, 11 nothing, 12 nothing, 13, 14, 15. When do I stop? Never, right? Because you never fill up a 10 with nothing. You never fill up anything with nothing. You can do it forever, and that's infinity. Now, why do most textbooks say, nah, it's not infinity, it's undefined? It's undefined. And by the way, the symbol is usually a U, sometimes with the line underneath. And in case you didn't know, this was the infinity symbol. Now, why don't they want to say infinity? So remember the inverse thing, right? Although it's multiplication division, no. So why do I need to make it work for the inverse? Well, they think you do. Is 0 times infinity anything? Well, it's not something specific. Let's use the example down here. Let's look at number 1. -20x divided by 0 is infinity. Or if you want to say undefined, knock yourself out. But here's why they don't like to say infinity. Is 0 times infinity -20x? Well, could be, because it's really every number. So technically, yeah, it is. But you could never get back to it all on its own. If I just gave you a problem and said 0 times infinity, would you know to say -20x? You wouldn't know to say that. Even though it is every possible number. And -20x is just a number, right? If x were 1, then the number's -20, right? It's just a number. So because of that, they don't want to say infinity, but quite honestly, it's infinity. When you get to calculus, it's infinity. When we do slopes in here this year, it'll be infinity. It's infinity, but they say undefined because of the inverse thing and whatever. All right. So on an achievement test, a lot of times you won't see infinity because they don't think you can handle it. They don't think you're smart enough yet. Your brain's not developed enough. We don't want to tell them it's infinity, so we tell them undefined. So you'll probably see undefined on any kind of achievement test. I'll take it either way. All right, so the second example, hey, 0 times anything is 0, right? So we definitely have a 0 on the bottom, and anything divided by 0 is infinity or undefined, and that's infinity or undefined. Is good? Got it? Sweet. All right, back to fractions. Fractions. You love them. You love them. All right, how do you divide fractions? Remember, you invert or flip the divisor and multiply. If you were to complete this rule, put the D on the top, put the C on the bottom, and do your R-bum on the multiplication step, right, before you multiply. All right, I'm going to one more time show you why this works. You don't need to write this in your notes. You can just look. I'm going to take A over B, and I'm divided by C over D. Right? This is just like the example there. A divided by B divided by C divided by D, right? A divided by B divided by C divided by D. What does the rule do? It's a shortcut. What I want to do is I want to get the denominator to be a 1. How can I do that? What if I multiply the bottom by D over C? Won't that give me a 1 on the bottom? But it's not legal, right? Can you just multiply the bottom of a fraction by something? No, because you'll change the value. However, whatever I do to the bottom, I need to do the same thing to the top, right? So what if I multiply the top as well by a D over C? I'm technically multiplying by 1. What happens on the bottom? It all divides out, right? Look at what the top looks like. It's the rule, right? That's where the rule comes from. Again, I took time in pre-algebra to show that to you. That's the reality, and that's where it comes from. And that's why the rule works. Okay, so why don't you guys do A and B? Do A and B. I'm going to pause. No R-bum on that one, huh? Negative 12/35 is the first one. Ooh, negative divided by negative is a positive, and we can definitely R-bum on this one. 2's are gone. Is that it? That's it. What do we get? 9/25. Everybody good to go? How many got both correct? All right. Easy. Piece of cake. Don't let the fractions cause you consternation. All right. Go ahead and do C and D. C and D. C and D. Don't forget, if everything's out of the numerator, you end up with a negative 1, right? In this case, negative 1 on the top, 20 on the bottom. This thing doesn't reduce, so what is that? Negative 75/7. How many got both of those correct? Beautiful for spacious guys. One more practice in our notes and then some homework. Try E. Try E. Try E. concur. Beautiful. Piece of cake. All right, don't forget quiz tomorrow. Anything up including today's lesson. Not going to use calculator again tomorrow just because we're still playing around with positive and negative numbers. By test time, you'll be able to use your calculator, so don't worry. And homework is there, page 31.